What's up guys, Francis here, and today I'm going to be showing you how to install an ArchLinux system on VirtualBox on a Mac OS X host. Although the procedure I'm going to be showing you today should be applicable across all hosts as long as you have VirtualBox. To start off, we have VirtualBox here, and basically this is a program that makes virtual systems within your computer already. And so you can see here I have FreeBSD. This is a FreeBSD system that I'm working on, and it works basically just by virtualizing all everything a computer system does with the hardware that your system has without having to reinstall anything permanently onto your hard drives. Okay, so basically if we look here, if we go to virtualbox.com, you can just download that right here. You can look through the documentation they provide to get familiar with the software. And along with downloading VirtualBox, you're going to want to go to the ArchLinux website and go ahead and go to the download section over here. And we're going to go to basically they have mirrors here for ArchLinux across the world, and so you're going to go to the one that's nearest to you. So I'm on the East Coast of the United States, so I'll probably look for Pitt should be NYU right here should be pretty good. So when you go to one of these pages, you're just gonna want to download the ArchLinux ISO, and usually they'll provide you with the latest one. So I already have this downloaded. If we move back here, I put it in a folder, VirtualBox VMs. I think it's a good idea to keep all of these ISOs in the same place. And so you'll see here I have all these different images of Linux systems. And so there's my ArchLinux system, my image right there of the installation. And we're going to use that, go back into the VirtualBox manager. We're going to hit new up here, name. We'll name this ArchLinux. And usually this program is pretty good about automatically detecting which system you're going to be using if you use that for your name. So that's all good. We'll hit continue there. Here we'll choose how much memory we want this virtual system to use. It says 768 megs is the recommended amount, but I like to play it safe and go up to 2 gigs here. We'll hit continue there. Hard disk. This is gonna be the section where you decide how much storage you want to give to this virtual system. So we'll hit create, continue here, and people like to do dynamically allocated because you don't use up all the space that you want to allocate right away. You only take up the amount of space that the system actually uses. But I like to do fixed size just because there's a lot less overhead on the system, and it usually makes the system faster overall. Here we'll actually allocate the storage that we want to use. Here I'll be using a 50 gig size hard drive for this whole system. So we'll hit create there. This will take a couple minutes, so I'll just speed up this process so you don't have to wait here with me. Alright, so it has created our system here. So what we want to do now is go into the settings of this basic system, and then we'll go to the system tab, and we're going to check this box right here, enable EFI for special. It says special OSs only, and ArchLinux is fortunately special enough for us to do this. So basically what this means is we're going to be using EFI or a GPT style partitioning table on our system as opposed to MBR, which is master boot record. And basically the difference between the two, MBR or master boot record has been used in a lot of the older systems. It's very reliable and it works well. The only thing is you can't use systems over 2 terabytes with this. And I know we're not going over 2 terabytes now, but if you want to expand your storage in whatever system you're using, it's best to use EFI. And plus, the technology today is all gearing towards using EFI or GPT in new systems. So I'll check that off. Then we'll also go to storage, because what we want to do now, since we have our system ready, we need to put in that that ArchLinux ISO. So we'll go to this empty, you'll see the CD-ROM symbol right here. Click on that and then click on the CD over here. And right here we'll be choosing which ISO we want to use for our installation disk. And so we'll click on the ArchLinux, hit OK on that, and then you're good to go. We can just double click on this system right here, and we'll come up here. It'll automatically boot into the installation. The first time you run this, since we are using an EFI system or a motherboard, it's gonna hang up a little bit on the first time you're running it. And so if you come up with a black screen here for the first couple of minutes, don't worry, that is normal. VirtualBox says so in their own manual. So just wait that out. I'll fast forward this section just so that we can save some time. Alright, so we're in the system now. And to be more specific, we are working in the installation in the ArchLinux ISO right now. So the first thing we want to do right off the bat is to make sure that we're getting internet on our system here. So we'll use the command ping. We'll use the option C space 3, and that'll just ping our destination 3 times for simplicity. Oh, another W there. We'll just ping google.com. It's usually pretty standard. And we'll see here that we do have internet. You usually are not going to run any problems because we are using VirtualBox. It does use the Wi-Fi that your host system is using, and it acts as a wired connection inside VirtualBox. And so it's usually pretty reliable on that in that case. After we've established that we have internet, what we want to do now is run this command lsblk, and what that stands for is list block devices, basically. And so once we do that, we see our list of devices here. We have SDA, SR0, and Loop0. The last two, SR0 and Loop0, we are going to ignore for now because we're not really going to need it for this installation. What we want to focus on is SDA, because if you look to the right of it, you'll see that the size is 50 gigs. The amount of storage that we allocated to it right while we were making this VirtualBox. And so what we want to do now, part 1 of this installation, is going to be setting up our partitions for ArchLinux and formatting them and also mounting them for the installation. And so basically ArchLinux all Linux systems use different partitions inside the system to do different things. And so I'll show you what these partitions are as we move along. So now that we know our drive is going to be named SDA, what we want to do now is run this command cgdisk, and this command will only work if you are doing an EFI system like we're doing right now, because it only works with GPT partitions. So we'll do cgdisk and then /dev/SDA. We'll do /dev because in every Linux system there is a folder named /dev, and what that does, it's a directory that holds all the devices in the system. And so SDA is a device. It's a hard disk within the system, and so that's why we're using /dev before we get to SDA. So I'll hit enter on there. It'll tell us warning, non-GPT or damaged disk detected. That's just because this disk is fresh and there hasn't been anything done to it yet. And so we'll just hit enter on that. We'll skip that message, and you'll see here cgdisk does give us a nice visualization of what we're doing here. Other commands will just be text, but here I think it's very good at showing you what you're doing in a very organized manner. So right now we have our free space highlighted, and what we want to do is create new partitions within the system. And specifically we'll be making 4 partitions here. One that'll handle our boot up, our boot partition. Another that will handle swapping, which I'll explain later. And then 2 for root and home. Those 2 I will also explain it later. What we want to focus on now is our boot partition. And so With your arrow keys, you'll be able to navigate to these different options on the bottom here. So we'll go to new. First sector we'll leave blank because it's choosing where on the disk this partition is going to start, and we'll always just want to leave that to the partition. We don't want to put that ourselves because we run the risk of not having continuous sectors. So we'll hit enter there. Size and sectors. Boot for EFI systems only needs to be 512 megabytes. So I'll put 512 MIB down there. Hit enter. Hex code or GUID. This code will help the system to understand what partition we're working with here. So it says L to show codes. We'll hit L, and while you're doing this, you can look through the codes. But I already know that for EFI boot, we will be using EF00, and you'll see that on the left column towards the bottom. EF00 is an EFI system code. So EF00, we'll hit enter there, and then enter new partition name. You can put any name you want. Oh, we're not doing swap. We're doing boot. So I will put that as the name down there, and you'll see that it comes up on the top here. Okay, so this free space will always be there. CG disk will leave that free space allocated right before your first partition. So we'll ignore that. We'll move on from our boot partition here, and then we'll move down with the arrow keys to navigate down to our free space again. We have 49.5 gigs left. That's good. All right, so we'll hit new again on our free space. First sector again, leave it alone. Size and sectors. Now we'll be working on our swap partition. What swap is it's basically a section on your hard drive that handles a situation on your computer when your RAM or your memory runs out of free space or is running too full. If there's too much going on in your memory, some of it will be allocated, some unused part of it is going to be allocated to this swap space to make sure the system is running smoothly and it doesn't hang up when it does start getting full. And so when this happens, what we want to do is make sure that our swap partition is 1.5 times the amount of memory that we have. And so if you look back in the video, or if you remember from before, we did allocate 2 gigs of RAM. So 2 times 1.5 is 3. So right now what we're going to do is allocate 3 gigs to our swap partition. So 3 GIB, hit enter on that. Hex code, again, we'll hit L, look at here, look through this list here. And if you look on the right hand column towards the top, you'll see 8200 is Linux swap. So we'll hit enter here, and we'll type in 8200. Enter new partition name, swap. Boom, there we go. Swap and boot is now done. Go down to free space again, and now we will be focusing on our root and home partitions. Basically what this is, as I said before, Linux does utilize a very specific file system, and they have specific directories that are found in every Linux computer. Basically, we want to allocate a separate root and home because root is going to be our main system, and so that's basically very similar to your C drive on a Windows computer. It holds almost everything, but we'll have a home partition on the side, and what that will do is that will be space set aside for users and their own data. And so some stuff like pictures, user specific movies, music, stuff like that, all of that will be in their home drive. All right, so what we want to do now is hit new on free space again. First sector we'll leave blank. Size, recommended size for a root partition is going to be 15 to 20 gigabytes, and so we'll do 15 GIB. Hex code, what we want to do here, look at L again, and then we'll look at Linux root. In the middle column, towards the top, we have Linux x86-64 root. That is what we are going to be using, so we'll use 8304. Hit enter, new partition name, root. There we go. You'll see partition type does show up there, and the partition name is correct, root. We'll go down, and then the rest of the free space can be used for your home directory. And so we'll hit new here, enter on first sector, enter also on the size in sectors. because that will just fill up the rest of the space. And then hex code, last time we'll look into here, we'll look for Linux home, and that is on the right hand column towards the top, 8302. We'll type in 8302 here, hit enter, new partition name is going to be home, and that's it, you're done. What you want to do now is navigate on the options at the bottom again, go down to write. Are you sure you want to write the partition table to disk? Yes. We'll type in yes, hit enter, let it do its thing. Operation has completed successfully. After you see that message, you're going to want to quit. And now we'll have to scroll down to the bottom here. Now we're out. If we run lsblk again to look at what we have, we'll see SDA is now partitioned into 4 different sections. SDA 1, 2, 3, and 4. And then you'll see under the size column, you'll see they correspond to the sizes that we made them in CG disk. That's good. Now, after we have partitioned these disks, now we want to format them to a specific file system, because since each of these disks, each of these partitions utilize, they do different tasks, and so very specific file systems are needed to do these tasks. What we're going to do first is handle our boot partition. And what we want to do is make that FAT32, because that is what Linux uses when it goes through the EFI bootloading process. So we'll do this command, mkfs.fat, so make file system.fat, and then we'll give it the option F32 for FAT32, and then we'll specify which partition we want to do. So again, we'll start with /dev, because that's where that is the directory that this device is found in, and then /sda1, because that is the partition that we made. You'll see that the size does correspond to the size that we made our boot partition. So hit enter there. That's done. What we want to do now is format our swap partition. This is very simple. All we do is do this command, mkswap or make swap /dev/sda2. Hit enter there. That ran fine. Now we want to initialize this swap, so we'll do swap on /dev/sda2. After we do that, swap is all finished, and all we have to do now is format our root and home partition, and we format that with ext4, which is I believe extended file system. So we'll do .ext4 /dev/sda3, hit enter on that. Everything went well there. We'll press up to go to our most recent command just for our ease here, and then we'll hit backspace and then do dev/sda4 for our home partition. There we go. So we formatted everything. The last thing we want to do now for part 1 of this installation is to mount them to our actual system. And so what we want to do is mount our root partition first. So we'll mount /dev. So what we're doing now is running this command. The first thing we want to do after typing this command is specify what you're mounting. So dev/sda3, because we are mounting our root partition. And then we want to specify where we're mounting it to. So /mnt. And you'll be seeing /mnt a lot while working with Linux, because /mnt is another directory that all Linux systems use. Very similar to /dev, but it's used for a very different purpose. Basically, whenever you're trying to mount a new disk, something like a USB or a CD-ROM, you're going to want to mount it into the /mnt directory to be able to be used. So we're going to mount our root partition right now. This is basically putting this into our actual system, letting it be used. Mount that, and then after we do that, we're going to want to make more directories within /mnt. So we'll mkdir, make directory or make folder, mkdir/mnt/boot, and we'll also do it for home. Swap, you'll notice that we're not doing one for swap because swap has already been taken care of. All we need to do is format it in make swap and then use the swap on command there, and then we're all done with our swap partition. Okay, after making these directories, what we want to do now is mount our partitions to these directories. So mount dev slash sda1, which is our boot partition, to slash mnt slash boot, and then mount slash dev slash sda, if you'll remember correctly, it is for our home partition, and then mount that to slash mnt slash home. There we go. So that's it for part 1 of the installation. We've correctly formatted, we've partitioned our disk, formatted all of the partitions, and mounted them to our system. Now we'll be moving on to part 2. Part 2 of the ArchLinux installation is actually installing the system. What we're going to want to do now is use this file. I'll show you here. So we'll run this command nano, and basically what nano is a text editor for basically any text file within your Linux system. We'll do nano slash etc slash pacman.d slash mirrorlist, and you'll see we start with etc. Again, another one of those directories that every Linux system uses. Slash etc will hold basically all your files that have to do with the configuration of the different programs within your system. And so this will be working within our config files for pacman. And so what pacman is the package manager for Linux, and what that does, it handles everything, all the programs that you download that you want to use. And so we'll look into this mirrorlist file here, and you'll see all of this, all of these things, all these lines are mirrors around the world that host all of ArchLinux's main packages, or main, like, officially supported programs. And so we'll exit out of there with Control X. What we want to do now is make a backup of this file, because we'll be manipulating the data, and we just want to make sure that everything is okay there. Everything is nice and safe in case we make a mistake. So what we'll do is cp for copy, cp slash etc slash pacman.d slash mirrorlist. So right there we're specifying which file we want to copy, and then next we will specify what file we want to copy this information to. And so we'll do slash etc slash pacman.d slash mirrorlist dot backup. Right? Hit enter on there, and then if we do go back to our previous command, except if we add the dot backup, we'll see we get the same file here. So we'll Control X again, because we don't want to work in there yet. And what we want to do, let's hit clear first to make our workspace a little neater. Now we want to run sed, because we want to uncomment all of the lines in that file, at least everything that has to do with a server. And so we'll do sed-i, and so basically we'll be replacing, right now we'll specify what we want to, what lines of strings of text we want to take and what we want to replace it with. So s slash this little hat or caret symbol, little hashtag sign, and then capital S server slash capital S again server slash, and then close that with an apostrophe. You'll see that we started it with an apostrophe as well. After we've specified what we want to replace it with, so basically anything that's server commented, we want to make it just uncommented regular server. And what we want to do that to is to slash etc slash pacman.d slash mirrorlist, right? After that's said and done, what we want to do now is run this command, rank mirrors. Rank mirrors is a command that comes within the ArchLinux installation, and what this does is it tests all of the mirrors that we have on our list and chooses the top 6 of each. So basically the mirrors that you have the fastest connection with, and it makes sure those are left uncommented, and those are the ones that we end up using when we use ArchLinux. And so we'll do rank mirrors, use this option N6, and this will tell us how many mirrors we want to select, and then we will specify the file that we want to rank. And so etc/pacman_d again, just the same file that we've been working with, mirrorlist. Okay, so we'll hit enter there. And so this is going to run for a while. This process usually takes about 10 to 15 minutes. So we'll let this run, and then I'll speed this up and we'll come back later to finish up our installation process. Okay, here we are back after our mirrors have been ranked. And so, sorry, our mirrors have been successfully ranked. It shows it right there, the 6 mirrors that it shows, which are the best that are around us. And so what we'll do now is install the actual base packages that ArchLinux uses. And so we'll do that by running the script within the installation environment, and that is pacstrap -i, and then we'll specify which partition we want to install everything in, and that will be our root partition, because again, as I explained before, root holds all the main programs of our system and all the main files. But before we do that, let's look more into what pacstrap is all about. So we'll do -h, which is the help option usually for commands. And so what we're doing with -i is, okay, so we're avoiding auto confirmation of package selections. Okay, so basically it's just going to prompt us whenever we're installing a package. Okay, so we'll do pacstrap -i again /mnt, because we want to put it into our root partition, because our root partition is mounted here, and then base and base -devel. These are the two packages that hold the very core of our Linux system, our ArchLinux system, and that includes command stuff, very how do you say, essential commands to the system. So stuff like IP-link, stuff like systemctl, which is sort of like a task manager for the system. That is all inside these packages. And if you want to know more about what's included in them, I'll hit enter here while I explain this. But if you want to know what's included in base and base devel, I would recommend going to the Arch wiki. They have very good information, actually. Everything that I'm showing you here. Oh, let's just confirm all of this right here. Type in Y, and then that'll download. Okay, so again, if you want to know more about what's in these packages, wiki.archlinux.org is the place to go. The ArchLinux community is very active in updating their documentation for everything, and so everything here is very reliable and usually pretty up to date. And actually, I have very good guides here. What I'm showing you, this process here, is based off of their beginner's guide. Because they do tell you how to install everything, but it's very cut and dry, and they don't explain exactly what you're doing when you're doing all these commands. So yeah, again, wiki.archlinux.org. Okay, so we'll move back here. We'll let this run again, do a little bit of waiting, but we'll come back after everything's said and done. Okay, now that we're done downloading and installing the base and base develop packages, what we want to do now is generate our fstab file, or fstab. Basically, what fstab is, it's a config file. Again, /etc, the /etc directory is what holds all the config files, so that's where we're going to find fstab. and it's a config file that defines how the system will mount the file system of disk partitions, block devices, and other remote file systems that the system will use. And basically fstab is referenced upon boot so that the system knows how to mount the different partitions that are on the system. And so the way we'll do that is we'll run gen fstab, gen fstab -u. Well, if we'll look at h again, gen fstab capital U, and we'll see up there, capital U lets us use UUIDs for source identifiers, -u, and that just basically means the source identifiers for the different partitions. And then we'll do /mount, and then so that's basically generate an fstab based on our /mnt directory, which is also our root right now, and then we'll output that to /mnt/etc/fstab. And so again, we're outputting that to basically mnt, which is again our root. This is acting as our root right now. Root, then etc, and then into the fstab file. So we'll hit enter there, and then real quick we'll double check that this generated the fstab right, nano/mnt/etc/fstab, because that's where we outputted it. And if we look here, it gives us all the information of the partitions that we want to be loaded on boot, that we want to be defined. And so we'll exit out of there since everything looks okay. Hit clear again, scroll back up to the top. After we do this, what we want to do is change root into our now installed system. So basically, we're going to be now working just within the actual system, because so far all we've been doing is working within the ArchLinux ISO, within the CD-ROM, the virtual CD-ROM that we loaded into the system before we even started it. Now we want to work out of that and into our actual system. So we'll do arch-chroot or change root into /mnt, because again, that is where our root is. There we go. Once you see that, that means you are now in your system. The root has been changed. And the first thing we want to do here is set up our language locale so that everything we see is set to the right language that we're using. What we want to do is go to our file locale.gen, and what we want to do is edit it. So we'll do nano again /etc/locale.gen. That will bring up this file. Basically, this will tell us which language locale we want to use. And right now, I am in the US. So what I'm going to be using is, let's do Control W. If we scroll down, it'll tell us that Control W is short for where is. So Control W, and then we'll do en_us.utf-8. That'll give us the first one up there. Control W, do it again, and it'll take us to the actual line that we need to uncomment to make sure we're using the right language locale. After we uncomment that, hit Control O to write it, to write the change to the file, and then after that's done, hit Control X. After we do that, we want to actually generate the locale, and that's just using the simple command locale-gen. There we go. So that's completed. What we want to do now is echo this line, lang equals en_us.utf-8, and where we want to output that is /etc/locale.conf. Again, you've seen me using this greater than sign. Basically, this is just outputting the command before it to specified output file here, which is in our etc. Again, what we went over, the directory that handles all config stuff, into our locale.config file. Hit enter there.
Now we want to export lang equals en underscore us dot utf dash 8, and that's basically adding it to if you've used env before in Windows and in Windows PowerShell or something like that environment, that will make sure that you are using the correct language locale, that make sure it's correctly set up within your environment. Next thing we want to do is set up our time. Usually this is already set up, but I'll go through this process just in case it isn't. So we'll change directory cd into slash user slash share slash zone info. After we do that, we want to run this command ls to list what's inside there, and it gives you a list of countries. So we want to cd into the country that you're living in. So I'm going to do America, and then we'll ls there, and it'll give us all these different regions inside America that are relevant to your time zone. New York, I would pick New York because I am on the East Coast. So what I'm going to do now is I'm going to run this ln-s slash user slash share slash zone info slash America slash new underscore York, because that's how they have it here, and we're going to output that to slash etc slash local time. And what ln is doing is creating a soft link to this zone info, or this time zone, and it's setting the link to this local time file in slash etc. Alright, so this will come up because, as I said before, this was already created in my system. Failed to create the symbolic link slash New York because the file already exists, but that's a good thing. After we do that, what we want to do now is set up the hardware clock. So we'll do hw clock --sys to hc, and then /utc for the time specification. There we go. Now that our time is set up, what we want to do now is set the host name of our system. So we'll echo whatever host name you want to come up with. I'll just put Francis here for my name, and then Arch to specify our system. And then we'll output that to /etc slash host name. Again, we want to double check that. So we'll go to nano slash etc slash host name. So if we scroll up, we'll see, yes, Francis dash Arch is in there. It has been appended successfully. So we'll Control X, exit out of there. After we do that, what we want to do is enable certain options within our package manager. And so what we want to do now is go to edit that config file for pacman or package manager. So we'll nano slash etc slash pacman.conf, and we get a file here. What we want to do is we'll be enabling something called multilib. And so we'll go to that real quick. We'll hit Control W, type in multilib, multilib. And we'll go down here to, you'll see multilib testing, and we'll ignore that. And then we'll scroll down to the one right underneath it, multilib. Delete these hashtags or pound signs to uncomment them. And basically what this is doing is making sure that we have access to the multi-libraries basically. And what that is access to 32-bit programs within pacman. We'll also be adding another custom package repository here, and so we're going to be adding ArchLinux FR. So here it gives you already basically what is it called, a nice setup for how you it's a nice template for setting up a custom package repository. So right under there we'll put in brackets ArchLinux FR. We'll type in sig level equals never, and then server equals http:// repo.archlinux.fr/$arch. Basically what this is doing is giving us access to the ArchLinux AUR, or the user repositories. These are custom repositories that are not officially supported by ArchLinux, but they do hold very useful programs that is recognized by the ArchLinux wiki. Packages that have to do with the AUR are handled instead of pacman. It uses this command called yaourt, or yaourt. You've seen before that we've done pacman. Oh well, you will see us use pacman, but yaourt is the same way, except it uses these user repositories. All right, now that we've set that up, we'll hit Control O to write these changes, and then Control X to get out again. After we've enabled multilib and added the AUR, we're going to update our system. So pacman-syu, and that's just an option to let us update the system. There we go. You'll see all of those things are up to date, and then it goes to multilib and then ArchLinux FR, and it updates the system with those options that we added to the pacman.conf. Okay, after we've done that, now we're going to set a password for our root. So we'll type in pass wd, and basically this is setting the password for the God account of your system, or the administrator account. And so we'll enter a password here, retype the password. There we go, password updated successfully. And now we're going to add a regular user for you to use, because you do not want to be using you don't want to be root all the time within your system, because it poses a lot of security threats, especially if your system is online. So what you want to do is create a user. So we'll do user add -m. This is an option that creates a specific home folder for this user, and then space -g, lowercase g, to specify what group this user is going to be in. That's the users group. And after that, we'll do -G. And these are basically like secondary. We're going to specify secondary groups that this user is a part of. So right now we'll do wheel, storage, and power. After we name those secondary groups, we're going to specify what shell this user is going to use, and that's -s to specify shell, and then /bin/bash. If you see here in the beginning, we have /bin. That's another one of the common Linux directories, and within /bin are common binaries that Linux uses. Okay, so after we specify that shell, what we want to do is type in the username that we want to use. So I'll use FCP3. Alright, so that my user has been created, so we want to set a password for that user now. So we'll do passwd and then specify the user, FCP3. Enter new password. So I'll type in this password, retype again. There we go, password updated successfully. So we've successfully created a user for this system. Now we want to create how we allow the sudo command, or super user do. And that's basically something you add to a command that lets you use the command as the root, right? And so what we want to do now is type in editor in all caps, editor equals nano vi sudo. And that's gonna take us, it's a special command to help to let us basically edit this this file that specifies how sudo and how root works in this system. So we'll do Control W, and what we want to search for here is %wheel. Okay, and if you remember when we were making my user FCP3, we did make wheel a secondary group that it's a part of. And so you'll see here, right above it says uncomment to allow members of group wheel to execute any command. So we'll uncomment that, but right underneath it we have to add this. This is very important. Default root pw. Okay, so basically what that does is you can execute any command as long as you know the password to the root account in the system. And so when you try to do sudo, what's going to happen is it's going to prompt you for the root password. Okay, after we do that, we'll write out those changes with Control O, and then we'll Control X because we're done with that file. And after we do that, we can install. We can install with pacman bash completion just for our convenience. And then after we do that, we're going to be installing the bootloader. Basically what the bootloader is the system that takes care of what happens after you press that power button on the system, and it handles basically the booting of the system. And so what we're going to do now is make sure that our EFI variables are here. So we'll run this command, mount-t EFI var fs EFI var fs, and then /sys /firmware /EFI vars, and it tells us that EFI var fs are already mounted, and that's a good thing. That shows us that EFI vars are our EFI system is working correctly. After we've confirmed that, we can go ahead and run bootctl install, and that is going to install everything you need for your bootloader. Okay, after we do that, what we're going to do now is edit our arch.config file, and basically what that does, it handles how our system is going to boot up. Okay, so what we want to do now is find the UUID of our root drive, because the system needs to know that on booting, and so while it's booting. And so what we'll do here is run blkid, right? So this is the block device ID, s part UUID, because that's what we want, and -o value of our root partition. So that would be, value of our root partition /dev/hda3. We want to use part UUID instead of this name, because the part UUID will always be the same no matter what for a partition that you created. So we'll do that. If we enter this command now, it'll just tell us what the part UUID is, but we want to output it to /boot/loader /entries/arch.conf, right? And so basically that's going to add this value to our arch.conf file, which does handle what's going on with our bootloader, right? So now we're going to go into that config file. So we'll do nano boot/loader/entries/arch.conf. We're inside it now, and our part UUID is here. Yours is going to be different on your system, and so we'll type enter because we want to insert things above that, and this is going to be the same for everybody's system. We'll add a line that says title space ArchLinux with capitals and a space, and then we'll move to the next line, type in Linux, and then space /vmlinuz-linux. After you do that, type in the next line, init rd space /init ramfs-linux.img. Okay, we'll move down to our part UUID, and before that, we want to before the part UUID, we want to type in options space root equals part UUID equals, and then we'll leave the part UUID that we added to the file in the first place. After that, we want to put a space in front of it and then RW for read write. Okay, so that's specifying our root file. It's specifying the title of our operating system and then these config informations in the middle. So we'll do Control O to write it out. Look here, Control O, Enter, Control X. Now, if you have an Intel processor, you're going to want to install this right after. pacman-s intel.ucode. Alright, well, -ucode. Install that, and then after you've installed that, we're going to want to add that ucode to our config file. So we'll go back up, nano/boot/loader/entries/arch config, right? This time, after the Linux line, but before the initrd, we're going to add another initrd line that says initrd space /intel-ucode.img. There we go. Now we're using our ucode, our Intel information on boot correctly. So we'll do Control O, write that out, Control X. After we've done that, that's about it for part 2 of the installation. Everything should be installed correctly now, and our system should be complete, in quotation marks, of course, because as of now, we do not have any kind of graphical user environment to use. Everything is still going to be in the terminal. So after we've done all that, correctly configured our bootloader, what we want to do now is type in exit to exit our root in mount. Then we want to unmount umount -r for recursive unmount /mnt. Alright, because we're done using /mnt because we only use that as a placeholder for our root since we were working in the original installation ISO for the ArchLinux. And so we'll unmount that, and after that, what we want to do is we'll go to we'll close out of the VirtualBox window, and we'll hit power off the machine here. Alright, after you've powered it off, what we want to do now is go to settings, then we'll go to storage because we want to take out this ISO since we're all done with installation, right? So we'll again go here, the little CD under the storage tab, click the CD to the right, and then remove disk from virtual drive. We'll hit OK there. The disk should be removed, and now if we boot into our ArchLinux, we should be able to boot into the actual system as opposed to the installation live CD. Oh, alright, looks like we have an error there. Alright guys, so we're back. I had to cut the video there because when we did restart our ArchLinux system without the installation CD, there was an error, and I fixed it, and what I had to do was, if you'll notice, if you go back to the video when we were editing our last arch.conf, our config file for ArchLinux, our boot config file, you can see that when I was typing in the last line, our options line, when I was typing in root equals part UUID, part UUID was not completely capitalized, and that's why we were getting a problem when I restarted the system. Basically, when ArchLinux references this config file, it's looking for very specific parameters, and if part UUID is not completely capitalized, it won't recognize it, and it's going to come up with an error. So just make sure when you're making that last file, you follow what I typed in exactly, except for the part UUID part. Make sure that is all capital. But after I did that, what I did to fix that was I went back, I put in the installation CD again, I mounted all our partitions like we did in the beginning of the video, and all I did was use our command nano to edit the file and just type that in with capital letters that time. After I did that, I took out the installation CD and I logged in, well, not logged in, but I restarted the system, and that is where we are right now. We are prompted with our login screen here
for our system with the host name Francis-Arch, and that means that we successfully installed the system. That's good, but we're not exactly there yet. This is our last part of the installation, which is the graphical interface. And so basically, the way our system is now, it's a terminal. And everything you're going to be doing on this, if you don't change or if you don't install some sort of interface, is just going to be terminal interactions. So we'll log in here with the username that I made before, fcp3, type in my password, and see we're still in the terminal. So now what we want to do, first off, let's see if we have internet connection. So we'll do ping c3 again, www.google.com. Name or service not known. This is because when you restart the system into your fresh, newly installed ArchLinux, you need to re-enable the service for using your internet. And so the way we're going to do that is, well, now we have to start using the sudo command because we are not root anymore. And sudo will just make sure that you run the command as root. Sudo systemctl, sort of like system control. This is like the task manager of ArchLinux, except it's much more powerful. You can start, stop, restart processes, and do a lot of other things from within this command. But what we're going to do now is enable, because we want to enable our internet service. And what we want to enable is dhcp-cd at our device for our internet. But alright, before we do this, let me show you which device we're going to be using. If we type in IP link here, this will show us what internet devices we're using. And if we look, what we want to look at is our device that says broadcast multicast here. We'll see that's number 2, ENP0S3. And if we go down, we'll see that the state is down, and we want that to be up so that we can use our internet. So what we're going to do, I'm going to type in that command I was typing before, sudo systemctl enable, because we want to enable it, dhcp-cd. This is just the controller for DHCP service within ArchLinux. DHCP-cd at, we're going to type in the name of that device there, ENP0S3 dot service, because everything that you're going to be running within systemctl is dot service. Alright, so we'll hit enter there. That they're going to ask us for the password for root, because remember what we did with the config file for our editor nano by sudo. This is why, because we want our sudo commands to be password protected. So we'll type in that password. Let's see here. Duplicate entry. Interesting. It says there's a duplicate entry in fstab. Let's see. We'll go to cd. We'll go back. We're gonna go to our etc directory right now. So cd/etc. I'm gonna do ls to list what's inside this directory, and we'll look at fstab. It looks like there's only one file in there. Let's do ls-al to give us a little more information. Okay. Alright, we might want to pipe this command. So we'll use the pipe, and we'll use more. And basically pipe will allow us to constrain this command by a second command. So more will allow us so that all this data comes up and we can scroll through it. Now it looks like we have only one fstab. Okay, we're out of that. Let's see if we do systemctl and then status of that service, we can see what's going on there. So dhcp-cd again at enp0s3 dot service. It is loaded, and it is well, it's inactive right now. Let's see what happens when we reboot the system. Sudo reboot. Okay. Okay, fcp3. Type in our password. Just log in here. and then let's test our ping again. Ping, let's see, 3 www.google.com, and we are getting internet. Okay, that's good. Now what we want to do is install our X server. What that is, an X server is basically, it takes in all this information that's in this terminal, takes in all that information and information of the processes that are going on right now, and serves it to us as Windows, as something that a user interface that we're familiar with, usually in Windows and Mac, because everything, of course, is all your programs and everything are in Windows. So what we want to do is do sudo pacman -s, because that's the option to install, and we're going to type in these packages: xorg -server, and then we'll do a space for another package, xorg -server -utils, xorg -xinit, and mesa. We'll type that in. Sorry, almost said my password there. Oh, all right. Let's actually type in my password correctly this time. All right, there we go. Enter, and we'll scroll down here. Type in Y, hit enter, and we will let that download. All right. So basically, what we're doing there is just installing the basic packages that we need for Xorg, which is sort of the default X Windows server for Linux. So yeah, we'll let that run, and I'll fast forward through it. Alright, so we're done downloading and installing all those packages. Now we want to, we're gonna download and install something else. Now we're gonna do xorg-twm, xorg-xclock, and xterm. The reason we didn't do all of these together is because it's just a little safer, keeping them separate so that we make sure we don't miss anything. That finished very quickly. One more thing that we have to install for now for our X server is sudo pacman-s. We're going to be installing Linux-headers, and that will help with the compatibility of some of the processes for the server, especially since we are within VirtualBox, and VirtualBox uses a very specific graphics adapter. It doesn't use your standard graphics adapter or graphics card that you might have in a desktop computer. So we'll install that. Yes, that should be quick. Okay, so after we do that, let's see here. Alright, we'll just let this run for a couple more seconds. But after we do this, we're going to want to install something called the VirtualBox Guest Editions. And basically, that is what the VirtualBox Guest Adapter will be. And so we're going to want to move our mouse up to the top here, go to the Devices tab of the VirtualBox VM, and then we're going to insert the Guest Edition CD image. This is going to be like the installation disk for our guest editions or our graphics adapter. So basically what we've just done to our VM is insert a CD. So as I said before, when we were mounting our partitions, whenever you insert any sort of external drive, you're gonna need to mount that too. So what we're gonna do is mount, and what we're gonna do is /dev/cd-rom, because that's where the CD-ROM goes. That's where it is when we inserted it, and we're gonna insert that, mount that into /mount again, because nothing is there right now. That's just a placeholder for any drives that we want to mount. Oh, only root can do that. So what we're gonna have to do is take that command again, put a sudo in front of it. There we go. So now we're going to change our directory into the mount directory, and we'll do ls. And we'll see all these things here. All the options in green are scripts, and all we're concerned about here is vbox linux editions.run. So what we want to do here is run that as an administrator, as our root. Type in sudo and then /vbox Linux, and if we hit tab here, it'll auto-complete it for us. So that dot slash there in the beginning is going to enable us to run the script. We'll let that run, and I'll fast forward through this because this might take 5 minutes. Okay, so it finished. What we're gonna do now is we're gonna run this. Oh, first, just to be safe, I like to run a system update, make sure everything is up to date before we do anything. Okay, so that's good. We're updating something. Okay, that's good. Now what we want to do is run this command start x, and this should start our X Windows server. And look at that. Everything is in Windows right now. This is just the base of our graphical user interface. So since this is working, this is a very good sign. We're just one step away from being able to look at this as a regular standard user system. So we're gonna exit here, X out of our X server, and there are only 3 other packages that we need to install. So what we want to do now is sudo again, pacman -s and GNOME and space gnome-extra. Now what this is, these are 2 packages for our GNOME display manager or desktop environment, and basically what this is what handles it. It takes in what our X server serves and shows it to us in a much more prettier display, and it also organizes everything and makes it very user friendly. And so we'll let this download and install. I'll fast forward through this again, and we'll come back later. Okay, so we're back. GNOME and GNOME Extra have been installed. Now what we want to do is install the last thing that we have to do, and that's going to be sudo pacman s for install and then GDM. This stands for the GNOME Display Manager, and that's going to be what ties together the last 2 packages that we just installed, and this is what handles all the work behind that. Put in our password here. Yes. Alright, so we just reinstalled GDM. What we want to do now is run an update SYU just to be safe. I always just like to do this just in case. Yes. So after that, what we want to do is start the GDM service. Okay, so what we're gonna do here is sudo systemctl, like we did before, enable gdm.service. Very similar to how we enabled our wireless card. All right, so we'll hit enter there. There's this thing that keeps coming up about a duplicate entry in etc fstab, but it's just saying right before it says it's trying to mount something that already exists. So I think we're going to be okay there. Now what we want to do is reboot, sudo reboot, and if everything went well, we should log back into an actual desktop environment, or our GNOME Display Manager desktop environment. Okay. And there we go. That is your ArchLinux system. As you see here, instead of having to log into our terminal, we do have our user show up here, and if we click on this, it'll prompt us for a password. We'll type that in here, and let's just let this run for a bit. The first time it might be a little slower, and there we go. We're in our actual desktop, full functionality here, and this is just your typical user environment. And let's just test out the internet real quick. And there we go. Everything is up to speed. I believe now we can go into full screen. We'll hit switch there. There we go. Everything is up to date. I think we should also take note that
we are using the GNOME desktop environment right now, but there are many others that you could use. For example, I'll show you. There's LXDE, which is a lighter, a very lightweight desktop. You might not think it's as pretty as GNOME, because GNOME is very popular because it is just it's very convenient and very pretty to look at. There's also XFCE4, and I'd really just go to the ArchLinux wiki just to familiarize yourself with these different desktop environments, read up on them, and figure out which one is the right one for you. But besides that, that's it. If you followed all my steps, you should have what we're seeing here, an actual ArchLinux system running within VirtualBox.